Hello class, this is ACSP Online Education, and you are with me, Master V, and then we're going to study English for mathematics. Previously on this one, we studied something called low sign in construction, okay? And we're going to do coordinate geometry today. Okay, for this level, we're going to study distance between 2 points, section formula, and then that's it for this video. Later on we'll do midpoint and equation of line. To study this, you are expected to understand analytic geometry and be able to apply it for problem solving. Okay, for distance between 2 points, it's actually easy if we can just like use the formula, this one, to find the answer, to just identify how long the distance between the two given points. But to make more sense of using it, so why don't we just try to prove it first by beginning with something like Pythagorean Theorem. Okay, if you consider the given point P x1 y1 here and x2 y2 here, okay, the distance between those two, okay, let's say P x1 y1 is here and x2 y2 here. Okay, the PQ, the length of PQ we're looking for, represent the distance between P and Q is here. So according to the Pythagorean theorem, if we can create a right triangle, just like in the picture, we have this size and this here, right? We got the right triangle already. Okay, PQ would be the square root of, because the PQ square equal to PR square, which is here, right? PR square plus QR square. So when I only need PQ, so I'll put square root on both sides, okay? So I'll get this one. Or if you don't get it, I can just do this, okay? Erase this one and I can write, okay, PQ square equal to PR square plus QR square. So I only need PQ, then I put square root on both sides of the equation. Then I get absolute PQ here. If you learn real number, square root of real number square is equal to absolute of that number. But since PQ is the length, so it cannot be negative, so we can just write PQ. And then PQ now equal to square root of, okay, PR square plus QR square. But because the given information here is the coordinate x1 y1 and x2 y2 here, right? So if we're going to use those numbers, we're going to change PR square and QR square to something about x1 y1 and x2 y2. So PR here is actually x2 minus x1 y, because if you look at the diagram, you use x1 y1 here, right? You use x1 y1 here, so that means on the x-axis that one represent x1 here, and that is x2 y2. So this line here, if you drag it to x-axis, that will be x2, right? And that will be y1 here, and y2 is supposed to be here. So QR then would be y2 minus y1. Then we can just use this x2 y2 rather than use PR. It's in the similar idea, we can just use y2 minus y1 instead of using QR here. Okay, so then we get x2 minus x1 square here plus y2 minus y1 square, and that's, it's supposed to be the proof of this formula here. Okay, so therefore the distance between P and Q, you can use PQ or you can use D, okay, is equal to square root x2 minus x1 square plus y2 minus y1 square. That's it. It's done. Now let's try find the distance between 2 points by using that formula. Okay, here's the given point. The other point, -3, 6, and 2, -6. Okay, -3, 6 would be here. Okay, that's -3, 6. And then 2, -6 would be here, 2, -6. And the length between these 2 points, or the distance between these 2 points, okay, let me represent it by this line here. Okay, the red line. Okay, we can find the distance between these 2 given points by using the formula. Since we didn't say which one is P, which one is Q, we can just say okay, because the distance represented by D, okay, distance formula, the distance formula is the equal to x2 minus x1, then we square, plus y2 minus y1 square. Therefore the distance between these 2 points is equal to square root of, okay, x1 y1 x2 y2, where is x2 minus x1? Okay, that would be x1 y1 and x2 y2. Okay, so x2 is equal to 2, x2 is equal to 2 minus x1, which is -3, and then square plus something square, something minus something. Now y2 minus y1, y2 is -6, y2 is equal to -6 minus y1, which is 6, and then it's become square root of 5 square, which is 25 here, plus 12 square, which is 144, then it is a square root of 169, therefore it's 13. Because we are looking for the distance, okay, so we say hence what? The distance is 13 units. Okay, that's it. That's the answer. Now, if you don't have any question where you can actually ask me now, so just move on to example 2 to help me. Okay, to make it quick, I already marked where is the negative 8 and where it's supposed to be 6, and the coordinate negative 8, 6 would be here, negative 8, 6, and the origin would be here. 0, 0 is the origin. Okay, 0, 0. Okay, that's the origin, and the distance between these 2 points represented by this line, line segment. And as usual, we're gonna use the formula. Okay, the distance between that 2 point, negative 8, 6, negative 8, 6, and then the origin. Okay, we're gonna have to decide which one x1, y1 and which one is x2, y2. Okay, so I might put x1, y1 here, x1, y1, x2 pair with y2 here. So the distance between these 2 points is equal to, okay, since the distance formula, just like the first example, x2 minus x1 square plus y2 minus y1 square, right? x2 minus x1 square plus y2 minus y1 square, and then d equal to something minus something square plus the y value, different of y value square. Okay, x2 minus x1 would be 0. Okay, would be 0 here. x1, x2, 0. Okay, minus x1, which is minus 8, plus y2 minus y1, which is 0, minus 6. And now it's become something easier, like 8 squared is 64, plus that one 36, and it's square root of 100. So that means this distance, therefore I can use the words therefore or hence. The distance we are looking for is equal to, it's actually equal to 10. Okay, 10 unit. Okay, that's answer for example 2. Okay, let's move on to example 3, so then we don't have to use too much time. Example 3, I illustrate the problem for you here. It's actually to make it quick, a point A is at a distance of square root 10 unit from the point 43. Okay, so here's the point 43. Find the coordinate of the point A. Okay, A could be anywhere anywhere on this circle here, because every point on this circle is square root 10 unit from the point 43. So it could be anywhere, point A, but there is some more condition here. If its ordinate, mean the y value is twice its abscissa, which is the x value. Okay, that's x, that's y. Okay, I mean, I supposed to do something like, okay, let point A be the point xy where the y is 2 times of the value of x, so I can just use a and 2 times of a, just like that, instead of writing x and y. Okay, so a could be anywhere on the red circle here, and now I highlight it as yellow. As long as the y value is equal to 2 times of the x value, it could be anywhere. But if you look at that condition, the ordinate is twice the abscissa, so then you can only get some point in this. So we're going to look for what point is that. Okay, where is exactly is A. So since the distance between 2 points, the distance between A and the point 43, let's say the point 43 located at B, then so let's say point B here. So the distance between A, B is equal to the square root of okay, x2 minus x1 square plus y2 minus y1 square, and we already know that AB is equal to square root 10. It's equal to square root 10, and then now square root 10 is equal to square root of x2 minus x1. You just say A is x1 y1, B is x2 y2, so x2 minus x1 now would be, okay, that would be x1 y1, and that is x2 y2. Okay, let me write x2 y2 there. So x2 minus x1 would be, x2 is now A minus x1, which is 4, and then we square, plus y2, what? I just say A is x1 y1, right? So I should have something different, like, okay, I should have x2 minus x1, I should have 4 minus a square plus y2, which is 3, minus y1, which is 2a, and then we square. Now square root cancel square root, or you can say you square root both sides and you cancel the square root of both sides. I mean, you square both sides and then you cancel the square root. What I said is this: we square up this side and we square up this side, and we get 10 equal to, okay, that part square will be 16 minus 8a plus a square, and for the other part plus 9 minus, what's that, 12a plus 4a square, and it become something like, okay, you put a square and 4a square together, it's 5a square. It's 5a square, and then negative 8a here with negative 12, so become, okay, minus 20a, and 16 here plus 9 will be 25, then minus 10 will be plus 15, equal to 0. So divided by 5. So you're going to get 0 equal to a squared minus 4a plus 3. And we're going to solve this quadratic equation by factorization if we can. And just come up with something like this. A minus 3, a minus 1. And then it's equal to 0. You use the zero product. So you're going to get a minus 3 here equal to 0. Otherwise, a minus 1 equal to 0. So that one makes a equal to 3 or 1. But the question is, what is the coordinates of the point A? So the coordinate of the point A is here, right? It's A, the point A. The coordinate of point A is A paired with 2A. So the answer will be the point A could be or R. Okay, if you use the X coordinate as 3, so you're gonna get Y as 6 because it's 2 times. Remember, the ordinate is equal to 2 times the abscissa. Otherwise, you get another point where A is 1 and then another one is 2. So that's the answer. And now look at the picture. That point would be here. 1, 2, and then 3 with the 6, where they are square root 10 from this point. Okay, that's square root 10. And the ordinate is 2 times the abscissa. Okay, so we don't need the yellow, and also we don't need that red circle here. We don't need it anymore now. It can only be that 2 point, which satisfying a problem. There are square root 10 from the point 43, and then the ordinate is twice the abscissa. Okay, so there are 2 possible point, 1, 3, 1, 2, and 3, 6. So 1, 2 is here, 1, 2, and 3, 6 is there. Okay, so that's it for example 3. So let's move on to the next topic, where it's section formula. So we're gonna have to understand analytical geometry and apply for problem solving. We start with something very similar to this formula. We're gonna prove this formula right here. Okay, the section formula, because we're talking about section, so it's this point P here will divide the line segment joining A and B into the 2 sections, where the ratio of the 2 sections is m to n. So I might write m here, n there. Okay, so to prove that the point P is equal to mx2 plus nx1 divided by m plus n, and then my2 plus ny1 divided by m plus n, we might start with something like, okay, P is actually, okay, we have A and B, the point A and B, right? We have the point A and B. Let's say point A is here, Okay, point A is here and point B is there. Okay. If we're gonna prove this formula, we might need to create something more than just, okay, the distance between these 2 points here, right? And then the point P is just located somewhere in between these two. And to prove that this point divide AB into a ratio of m to n, we might have to create the triangle here, the right triangle here, and another one. We use the idea of the similar triangle. I will use the green little triangle there rather than use the blue big triangle here because it's make it more difficult. So I won't use that blue. I will just use the yellow and the green. Okay. To prove it, you might start with, okay, we're gonna need quite some space there. Okay, you're gonna have to understand this formula. If you write something like that, it means the x value here is equal to this part and the y is equal to that part. Okay, so I'm gonna prove each of the part. First, we'll start with, okay, we're gonna have to prove, so that means we're gonna have to show that x is equal to mx2 plus nx1 divided by m plus n, and the value of y is equal to, will be my2 plus ny1 divided by m plus n. But it doesn't look like we're gonna have enough space here to prove all of them, so I might just prove x to you and then leave the y for you to do it by yourself. Okay, to prove that x equal to this mx2 plus nx1 divided by m plus n, we might start with, okay, since we have the ratio of m to n here is equal to, okay, because m is the length of the bigger triangle here, the yellow triangle, and the n is the length of the green triangle here, and they are similar triangle. The concept of the similar triangle, the ratio of the corresponding side is, you know, somehow related to each other. So m divided by n, or m to n, is equal to that part here to this part here. So this one will be x minus x1, x minus x1, because that is the point xy in here, so that part is x. Okay, x minus x1 there, and this one should be x2 minus x. Okay, if you don't understand, you can try draw x and y axis. Okay, let's say maybe if you think about the axis, it might look like that, x axis, and then the y axis could be there. Okay, so if it's x1 y1 at a, so that at that point that will be x1 here, x1, and that will be x, and that will be x2, right? And if you look at the y, that will be y1, because this point A right here is x1 pair with y1, so this x1 pair with this y1 become point A, and so therefore y2 should be here. Okay, y2. Okay, y2 should be there, right? Anyway, what I needed, this length here, and this. So m to n is equal to x minus x1 to x2 minus x, and we're gonna have to prove that x is equal to this x2 plus nx1 divided by m plus n, right? So let's make it quick. How do we get that? How? Okay, we're gonna have to cross multiply, right? Cross multiplication here. So we're gonna get m and n, okay? mx2 minus mx minus mx. Okay, let me do this. mx2 minus x equal to n x minus x1, and we're gonna get mx2 minus mx equal to nx minus nx1. Okay, what do we do now? We're gonna have to put x with x. So we have this x here and that x, all right? We're gonna move it, put it together, maybe on the left hand side. So we're gonna get and in the same time I'll factorize it. We're gonna get x times negative m minus n, right, equal to, on the other side you get negative mx2 minus nx1, right? And then you get something very close to that. Anyway, so I'm gonna get x equal to let's take minus out here, so we're gonna get mx2 minus nx1 divided by that value here, okay? And then let me write it up there. So x is going to be mx2 minus nx1 divided by m plus n, because you can maybe put that form here. You have negative there, right? And when you divide it by minus m minus n, you could take out a common factor, minus and minus, and it's cancel, right? So you're gonna get that formula, x equal to x mx2 plus nx1 divided by m plus n, just like that. Okay, if you have some time, if you don't understand, I should say come talk to me, but since you can't come to school, so maybe ask me through the line or some sort of that, Anyway, go to the example. Okay, example 1. Calculate the coordinate of P which divides the line segment joining A, B in a ratio of 1 to 2. So I'm gonna think of this as x1, y1, and that is x2, y2. Okay, the point P is in between, where it separates the distance between, yes, A to B into the ratio of 1 to 2. So you're gonna have to dividing that one into 3 equal parts. So this is one part, and that's another one part. So that point P would be here, and the ratio of m to n should be 1 to 2. So that means m equal to 1 and n equal to 2. And we're looking for the coordinate of point P here, right? So since P xy is equal to mx2 plus nx1 divided by m plus n, and then my2 plus ny1 divided by m plus n, right? And m equal to 1, n equal to 2, so we're going to get something like this. M equal to 1, so I'll put 1 here. x2 we don't know yet, we'll decide it later, plus n equal to 2, right? And then x1 divided by m plus n for the y. So we get m y2 plus n y1 divided by m plus n, whereas 1 plus 2. So we now know that down here is going to be 3, and then that will be 3 as well. So x2 now is equal to 5 plus nx1, which is 1, my2, which is 9, y1, which is 3, and now it's become 7 on top of 3, and then that will come 15 divided by 3, and at the end the point PQ, so therefore the points xy, it's 7/3 paired with the number 5. Okay, that's it. That's the answer. Okay, so the point PXY here is 7/3 and then 5. If you have some time, look on the diagram if it makes sense. Okay. Now, shall we go to example 2, where we have to find the coordinate of the point of the trisection, the point of trisection. Okay, that means we're going to have to separate the line joining this point and this point into 3 equal parts, and I'm going to have to find each of the points dividing this line into 3 equal parts. So let me illustrate it by using the diagram here. We have -3, 0. Where is it? -3, 0 should be, okay, -3, 0 here. And another point 6 pair with number 6. And we're looking for the point P. Okay, we're looking for P on this line. Where it's dividing the line into trisection, mean 3 equal parts. So I guess it's about that point and that point, but we have to locate it exact coordinate. Think of this as P, and that is Q. We're gonna have to find the point P and Q. Okay, since it's quite similar to example 1, so I'll just give you some hint. If we're gonna find point P, we're gonna use to find P, P, we're gonna use m to n equal to 1 to 2, and to find Q, to find Q, m to n would be 2 to 1. Okay, and then you can start with, okay, since the point pxy would be mx2 plus nx1 divided by m plus n, and my2 plus ny1 divided by m plus n. Okay, and you plug in the value m and x1 y1, and you get the point P, the same as the Q. So you can start with qxy equal to that, quite the same formula, and you plug in the value by using different m and n, because to find P you use m to n equal to 1 to 2, and to find the Q, m to n would be 2 to 1, and you get the different coordinate between P and Q. Okay, so supposed to be easy. Let's see example 3. That would be the last example for today. Example 3, the 3 given points are given. Okay, let's say the point negative 5, 2 would be A, and then 3, negative 6 would be C, and then O would be B, and then C would be 7, 4. The vertices of the triangle are there. Just like I said, find the length of its median. Okay, the problem is this. Its median. What is the median? The median is what? Okay, the median is the line segment joining each vertices to the midpoint of the opposite sides. So go here. Okay, separate that. I mean, it's bisect this line into 2 equal parts. So if we do that to this, we're gonna get this, and also that line for another vertex. And the property of the median is it's intersecting at some point, and that point called centroid. Okay, we're gonna learn centroid in the next one. Anyway, it's divide the median into the ratio of 1 to 2 here, and also 1 to 2 here, and 1 to 2 or 2 to 1. It depends on you come from that size. Okay, anyway, the question here is find the length. Okay, find the length of the median through the point 3, negative 6. So we're looking at this point right here, and we want to find the length of the median here. Okay, so you're going to think of the distance between 2 points. So if you have A, B, C, now I should name this point D. And if you know the coordinate of the D, so we can use the distance formula, okay, between B and D. So BD would be square root of x2 minus x1 square plus y2 minus y1 square, and it's equal to, okay, x2, because it's BD, so x2 would be at D, and D is the midpoint between A and C, and we don't know the formula for the midpoint, so but we know the section formula. Because D is the midpoint, so it's dividing A to C by the ratio of 1 to 1. So M would be 1, N would be 1. If we're going to use the section formula to find D here, so we need it. We're going to have to find that one. Okay, so we're going to have to find D first. Let me find D first then. Find dxy first. So we're going to get dxy equal to, okay, I'm not going to write the formula because we don't have enough space here. Dxy would be mx2 plus nx1, where m is 1, n is 1, so I don't need to write that. Okay, so mx1, x1 would come from A, so it's gonna have to be, okay, let me write m and n. So m is 1, mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n. So we're gonna get we're gonna replace x2 y2, okay, x1 y1, so I would think of this as x1 y1, and that is x2 y2. Okay, mx2 plus nx1, mx2 would be 7 here, plus nx1 would be -5 divided by m plus n, and then my2, which is 4, plus ny1, which is 2. Now D is going to be, dxy is going to be the point 7 minus 5 would be 2, divided by 2 would be 1, and then that will be 6 divided by 2 would be 3, so it's 1 3. Okay, 1 3, right? Okay, since we know D already, and now we are looking for the length BD as the length of median to the point 3, -6. So BD equal to square root of x2 minus x1 square plus y2 minus y1 square. So BD is going to be square root of, okay, because BD, so x2 would come from D, so that's x2 y2, so x2 is equal to 1 minus minus x1, which is from B, is 3, and then square, plus y2 minus y1 and then square, and then BD would be square root of, okay, that one go to 2 square is, or -2 square is 4, plus that one go to 9, and then 9 square is, oh, is it 9? 9, yes, it's 81. So it's square root 85. So that answer the question. The median, find the medians of the triangle through the vertex 3, -6 to this one. So we'll find the length of this line here, and it's equal to square root 85. That's what we do here. Okay, oh, I should write something like hence the median through (3-6) is square root 85 unit. Okay, that's the answer. That's it for our example and about distance and section formula. I hope it's useful for you to try some exercise here I prepared for you and a few of the ICSE past exam. Thank you very much for listening. See you next video.